Hello there. My name is Michael Tawonga Kamanga. I welcome you to today's lesson. Um, in today's lesson, I'll take you through physical and chemical changes. So, under physical and chemical changes, we will look at the calculation of formula masses. So, in physical and chemical changes, so far, we have looked at the balancing chemical equations, writing chemical equations, writing chemical formulas. So all these are coming from chemical changes. Remember, in a chemical change, there is a production of a new substance. So the chemical changes are the ones which use a chemical reaction. So a chemical reaction is represented by a chemical equation. So a chemical equation is just a shorthand showing or illustrating or giving a summary to the chemical reaction. So the chemical reaction comes from the chemical change. Remember, the physical changes usually they are temporal and they do not lead to the formation of a new substance. But we are much interested in the chemical changes because these are the ones which use a new substance known as a product. So be with me as I'll be taking you through this topic of physical and chemical changes, more especially calculation of formula masses. So be ready because we'll be doing some calculations. So please, you can participate as well. Well, for this class, for this lesson, our success criteria is by the end of this chapter, you should be able to calculate formula masses. Calculate formula masses. So by the end of this chapter, you should be able to calculate formula masses. Okay, so before we go direct or straight into how we calculate the formula masses, we should remind ourselves on the chemical reactions because it is very, very important to connect the two because we cannot just go straight in the calculation of formula masses. We should have a recap on the chemical reactions. So remember, chemical reactions are very, very important. Um, in chemical reactions, uh, substances known as the reactants, they do undergo alteration or transformation to form new substances called products. Understanding chemical reactions is crucial for various scientific fields, including chemistry, biology, environmental science, and engineering. So this is very, very important. A chemical reaction involves the breaking of chemical bonds in the reactant molecules and the formation of new bonds to produce products. This process results in a chemical change. It changes the chemical composition of the substances involved. So the reactants, they will undergo a transformation, they will undergo alteration. As a result, they will no longer be the same. They will be completely new. No wonder we're saying in chemical reactions, we are producing new substances known as products. Please take note. And the chemical reactions and the chemical changes, they go hand in hand. They are closely related concepts in chemistry. And understanding the relationship helps in grasping how substances interact and transform. So they work hand in hand. They are closely related concepts in chemistry. And if you understand them, their relationship helps in grasping how substances interact and transform. So a chemical reaction is simply a process in which substances known as reactants. They will undergo a transformation to form new substances known as products. So this transformation involves the breaking and forming of chemical bonds. So chemical reactions are characterized by changes in energy, color, temperature, and the formation of new substances with different properties. So take note of that. The transformation, how are they transformed? They are transformed because they will be bond breaking. The bonds holding the reactants together will break down. Once they break, they will rearrange and then form new bonds. So if they form new bonds, then they are forming new substances. No wonder in the chemical changes, we always stress on the formation of new substances known as products. This is very, very crucial. This is very, very important. Now, by definition, we can define a chemical change as a process where the chemical composition of a substance is altered, resulting in the formation of new substances with different properties. Chemical changes are a direct result of a chemical reaction. Yes, so a chemical change is taking place because of a chemical reaction, where bond breaking, then the rearrangement and bond formation will result to the formation of new products, new substances. We have several examples of a chemical reaction or a chemical change. You talk of iron, rusting in iron. You talk of, yes, mixing of ingredients when you are baking. You have several examples around you. You can share more and more examples in the comment section. So we have many examples of chemical reactions. And then these chemical equations, yes, the chemical reactions, the chemical reactions are summarized using a chemical equation, or they are represented using a chemical equation. So the chemical equation gives a summary of a chemical reaction. It is showing you, it is telling you what is going on. So you say reactant A is reacting with reactant B to produce product C. So this is a statement. How can I present this statement? We use a chemical equation. And previously, in the previous lessons, you have seen how we write a chemical equation. Yes, reactants, left-hand side, products, right-hand side. These two are separated by an arrow. So this is how we represent a chemical equation. So chemical equations are symbolic representations of chemical reactions. They use chemical formulas to represent reactants, the starting substances, and products, the substances formed in a reaction. Please take note of that. So a chemical equation, remember, it has its own key components. And remember, a chemical equation, it is supposed to be balanced as well. Yes, just a quick recap on the key components of a chemical equation. We have reactants, we have products, we have an alloy, we have a coefficient. So all these, they must appear in a chemical equation. Reactants, left-hand side, products, right-hand side. Alloy, separating the reactants and the products. Then the coefficients, these are simply numbers placed before formulas to balance the number of atoms of each element on both sides of the equation. So this is very, very relevant. In a chemical equation, we also have state symbols. which indicate the physical state of the substances: solid, liquid, gas. Small letter S for solid, small letter L for liquid, small letter G for gas, small letter A and a Q for aqueous solutions. These are special solutions in which water is the solvent. So such solutions are known as aqueous solution. Okay, now let us look at formula mass, which is also known as molecular mass. Formula mass or molecular mass. This refers to the mass of a single formula unit of a compound, calculated by summing the atomic masses of all the atoms in the formula. This concept is crucial in chemistry for understanding the mass relationships between substances in a chemical reaction. So it is very, very crucial. It is very, very important. This concept is crucial in chemistry for understanding the mass relationships between substances in a chemical reaction. So yes, we have learned on how we can write the chemical formulas. Remember, the chemical formulas, they have elements, atoms. Water, it is made up of hydrogen and oxygen. Hydrogen has its own atomic mass. Oxygen has its own atomic mass. So since water, the formula is H2O. If we combine, if we sum the mass of hydrogen and the mass of oxygen, what we have now is the molecular mass. No wonder we are saying it is the mass of a single formula. So only the definition of a formula mass, it is the sum of the atomic masses of the atoms present in one formula unit of a compound, expressed in atomic mass units, AMU, or grams per mole, that is G per mole. So it is the sum of the atomic masses of the atoms present in one formula unit of a compound, expressed in atomic mass units or grams per mole. Now, formula mass versus molecular mass, are they the same? From the two definitions. Well, molecular mass typically is used for covalent compounds, where molecules are distinct entities. It is essentially the same as formula mass, but specifically refers to the molecular mass. So this one is for covalent compounds, molecular mass. If it is an ionic compound, you say it is a formula mass. But it is more like the same. They're just you're just stressing that this is for formula mass, and this is for ionic compounds, and this is for covalent compounds. But in terms of number, it is the same. For formula mass, it is more general, used for both ionic compounds and covalent molecules. So in general terms, we use formula mass because this one takes everything on board, whether it is ionic or covalent. But if it is covalent, we say it is molecular mass. Please take note of that. An example of an ionic compound, there is sodium chloride there. An example of a covalent molecule, you have water. Formula mass is an essential concept in chemistry, representing the total mass of one formula unit of a compound. It is calculated by summing the atomic masses of the constituent atoms, reflecting both the identity and quantity of atoms in the compound. This calculation is fundamental for understanding stoichiometric relationships, reaction yields, and properties of substances. Yes, the formula mass is very, very essential because it assists in calculations. Because in stoichiometry, you are looking at the numerical relationships between the reactants and products. So for you to come up with the correct relationships, you are supposed to work out the formula masses. Not only that, they also assist in reaction yields and even properties of substances. So you'll be assisted using the formula mass. So the formula mass is indeed relevant. It is very, very important. So if we use formula mass, we have seen that we can use it in a number of ways. So let us learn how do we work out the formula mass. Here we are just giving a summary saying you sum up the atomic masses of constituent atoms. You sum them up. You sum them up. On calculating the formula mass of a compound, it involves determining the mass of a single formula unit based on the atomic masses of the constituent elements. This process is fundamental in chemistry for understanding the mass relationships in chemical reactions and is critical for stoichiometry. So when you are calculating the formula mass of a compound, it involves, first of all, knowing the mass of a single formula unit based on the atomic masses of the constituent elements. So, what are the steps? The steps which you are supposed to follow when you want to calculate the formula mass. First of all, you have to write the chemical formula. You identify the compound, you determine the chemical formula of the compound you are interested in. The formula indicates the types and quantities of atoms in the compound. So you have to identify the compound, write the chemical formula, issues to do with valences. So you will need that information as your prerequisite knowledge. Write the chemical formula, identify the compound. You have to identify the compound, you determine the chemical formula of the compound you are interested in. The formula indicates the types and quantities of atoms in the compound. A quick example, it is glucose. And the chemical formula for glucose is C6H12O6. C6H12O6. So you write the correct chemical formula. Don't just write any other formula, but it should be a correct formula. Then from there, you have to determine atomic masses. How do you determine the atomic masses? You use the periodic table. In most cases, if you have a question, you are given the relative atomic masses. But you can always use the periodic table. So you use the periodic table, you find the atomic masses of each element from the periodic table. Atomic masses are typically listed in atomic mass units or grams per mole. Take note of that. So the periodic table, it is there to guide you as far as the atomic masses are concerned. You have carbon, hydrogen, oxygen. Carbon, it is approximately the atomic mass of carbon is 12.01 atomic mass unit AMU. Hydrogen, approximately it has a atomic mass of 1.01. Oxygen, it has an atomic mass of 16. Please take note of that. However, if you check on the periodic table, some they don't give round off figures. For example, for oxygen, you can find that it is 15.99999. So they were just rounding off the figure. Don't be surprised. But all in all, the periodic table will assist you in knowing the relative atomic masses. Then from there, you have to calculate the mass of each element in the formula. You calculate the mass of each element in the formula. You multiply the atomic mass by the number of atoms. As simple as that. So on calculating the mass of each element in the formula, you are doing it by multiplication. So you multiply the atomic mass by the number of atoms. So for each element in the formula, multiply the atomic mass by the number of atoms of that element in the compound. For each element in the formula, multiply the atomic mass by the number of atoms of that element in the compound. For example, glucose. For glucose, remember the formula is C6H12O6. So glucose, we have carbon, we have hydrogen, and we have oxygen. Now, you have to identify that yes, I have carbon, yes, I have hydrogen, yes, I have oxygen. But how many atoms of carbon do I have? How many atoms of hydrogen do I have? How many atoms of oxygen do I have? Knowing that will assist you in calculating the correct formula mass. So for example, here we have 6 carbons. Remember, the subscripts always represent the number of atoms. Here for hydrogen, we have how many? 12 hydrogen atoms. For oxygen, how many? 6 oxygen atoms. So indeed, there are 6 carbon atoms. There are 12 hydrogen atoms. If you check on the periodic table, we said the atomic mass of carbon is 12.01 AMU. And how many carbons do we have? 6. So it will be 6 multiplied by the atomic mass, which is 12.01. And we're getting 72.06 AMU. That is for carbon only. From there, hydrogen. How many hydrogen atoms do we have? 12. And what is the atomic mass for hydrogen? 1.01. So you say 12 as the number of atoms multiplied by the relative atomic mass, 1.01 AMU, which is 12.12 AMU. So now we know that the mass for carbon is 72.06 AMU. The mass for hydrogen is 12.12 AMU. We are not ending there because there's oxygen as well. So we have only calculated for carbon and hydrogen. What about oxygen? For oxygen, there are 6 oxygen atoms. Mass of oxygen, that is the 6, that is for the number of atoms, multiplied by 16 as the atomic mass of oxygen. So 6 multiplied by 16, we are getting 96 AMU. 96 AMU. From there, what next? You have to sum the masses of all elements. Sum them up. So for carbon, for hydrogen, and for oxygen, you add them, sum them, add together. Sum the total mass contributions of each element to find the formula mass of the compound. To find the formula mass of the compound. So for glucose C6H12O6, the formula mass will be 72.06 AMU for carbon, plus 12.12 AMU for hydrogen, plus 96 AMU for oxygen. If you do that, the total formula mass now is 180.18 AMU. 180.18 AMU. That is the formula mass of glucose. So this is very, very important. Make sure you use your periodic table to know the atomic masses. Make sure you break down the compound where you say this compound is made up of this atom, and this atom. Then you multiply the number of each atom versus its atomic mass. After that, then you add. And what you are getting is the formula mass. Express the formula mass. So the units. The result is typically expressed in atomic mass units when dealing with individual molecules or formula units. For macroscopic amounts, this value is also represented as grams per mole. Grams per mole. But 1 AMU is just equal to 1 gram per mole. So nothing is changing there. So we can also have another detailed example, sulfuric acid. The chemical formula is H2SO4. Then we have hydrogen, we have sulfur, and we have oxygen in sulfuric acid. And then for hydrogen, the atomic mass is 1.01 AMU. For sulfur is 32.07 AMU. For oxygen is 16.00 AMU. From there, calculate the mass of each element. Calculate the mass of each element. So for hydrogen, there are 2 hydrogen atoms. Mass of hydrogen, that is 2 times 1.01 AMU, which is 2.02 AMU. Then from there, sulfur, there is 1 sulfur atom, and the mass of sulfur is equal to 1 times that is, yes, 1 atom times 32.07 AMU. Then you are getting the very same 32.07 AMU. Then finally, for oxygen, there are 4 oxygen atoms. So mass of oxygen will be 4 times 16.00, which is 64 AMU. Then finally, you sum the masses. You sum the masses. So formula mass, you add the mass of hydrogen, sulfur, and oxygen, which happens to be 98.09 AMU. 98.09 AMU. Okay, now in summary, the formula mass is calculated by summing the weighted contributions of each element in a compound based on their atomic masses and quantities in the formula. This calculation is fundamental for converting between moles and grams, understanding reaction stoichiometry, and calculating yields in chemical reactions. So it is very, very important, the formula mass. It is very, very important. Okay, now reaching this far, there's an activity for you to do here. Remember, always your answers, your participation is always welcome. You can write your answers in the comment section. And remember always to go through my suggested answers as well. It is very important. And you can research for more questions and answers as well to supplement on the knowledge which you have gained today. Question number 1, calculate the formula mass of ammonium nitrate. 2, determine the formula mass of calcium carbonate. Then find the formula mass of acetone. Then calculate the formula mass of potassium dichromate and determine the formula mass of magnesium sulfate. If you have any questions, you can use this WhatsApp number or help@xulendo.org. You can also visit Xulendo online, xulendo.org. Please, we need your feedback. Feel free to ask and you'll be answered. For resources, I've used Excel and Succeed Junior Chemistry Book 1, Achievers in Chemistry Book 1, Django Chemistry Book 1, Samuel Kalea Chemistry Book 1. Illustrations, design, and graphics were done by Charlotte Bloning and Dave Mumba on Work Xulendo. For the photos, we have the link for the photos. You can feel free and visit the link. Well, until we meet again in the next lesson, bye-bye.